All right, question 2 for the 2019 AP free response. So it says researchers are investigating the effectiveness of using a fungus to control the spread of an insect that destroys trees. The researchers will create 4 different concentrations of fungus mixtures: 0 milliliters per liter, 1.25, 2.5, and 3.75. An equal number of the insects will be placed into 20 individual containers. The groups of insects in each container will be sprayed with one of the 4 mixtures, and then the researchers will record the number of insects that are still alive in each container 1 week after spraying. So part A, which part A seems easy, but there's common mistakes here. Identify the treatments, experimental units, and response variables of the experiment. Treatments. The treatments should be nice and easy. The treatments are what are you applying to each unit? Well, the treatments are 0 milliliters per liter, 1.25 milliliters per liter, 2.5 milliliters per liter, and 3.75 milliliters per liter. Common mistakes are amount of fungus. No, treatments you want to be as specific as possible. Keep that in mind. Experimental units. Now, this is where we make mistakes. The experimental units are not the insects. It's not, because the insects are not being treated as individual cases. The experimental units, you either have to say the 20 containers, or you have to say the group of insects in each container. It has to be one of those two. If you say the insects, you will not get credit for that part. Response variable, also something that we make a mistake with. If you say the number of insects still alive and stop, that is incorrect. It is the number of insects still alive in each container. You're measuring in the containers how many insects were alive. Now, part B, does the experiment have a control group? Yes, there is a control group. What is the control group? The control group is the group that is sprayed with 0 milliliters per liter of fungus. So, state yes, and then explain why that is a control group, because it's not getting any of the treatment. It's not getting anything different than it wouldn't if the scientist did not intervene. And then part C, describe how the treatments can be randomly assigned to the experimental unit so that the treatment has the same number, so that each treatment has the same number of units. Now, you could have done this with pieces of paper. The way I would have explained it with pieces of paper, and be careful here too, because usually we're not thorough enough, I would say, on 20 equal sized pieces of paper, list 5 number 1s, 5 number 2s, 5 number 3s, 5 number 4s. Number 1 will apply to the treatment of 0 milliliters per liter, 2 to 1.25 milliliters per liter, 3 to 2.5 milliliters per liter, and 4 to 3.75 milliliters per liter. Then, randomly select, pick a container, randomly select out of a hat, shake the hat, shake the hat, then randomly pick a number out of the hat for container 1, it will get that treatment. Continue this process 20 times. This will ensure that each treatment is present in 5 of the containers. Or you could do it the way I did it. Let's read what I wrote. To randomly assign the treatments to the containers, assign a number 1 through 20 to each container. Use a random number generator to select 5 containers without repetition. These 5 containers will receive the first treatment, 0 milliliters per liter. Then, renumber the remaining 15 containers and use a random number generator again to select 5 containers without repetition. These 5 will receive 1.25 milliliters per liter of fungus. Repeat for the remaining 10 for the 2.5 milliliters per liter, and then the last 5 chosen the last 5 not chosen will receive 3.75 milliliters per liter. So just, again, a tip for part C, be thorough. Imagine that you were trying to carry this out, or you were trying to give directions to someone else to carry it out, and you did not want them to screw up or miss any steps. Be very thorough. And that's question 2.